Okay, so we're now moving on to data representation and interpretation, basically the graphs that are involved with statistics. Firstly, every time that you're asked to do a box plot, make sure that you've done your outlier calculations before you start to sketch anything. So the very first thing is to identify any outliers. All right, so as usual, we should be using our 1.5 times the interquartile range and putting our values into there. All right, so if we work out our outlier boundaries, we've got negative 3.5. None of the values are below negative 3.5, so we're good. We work out the upper outlier boundary. 24.5 is the boundary, and we can see here that 25 is going to be an outlier. So straight away, we know we have an outlier at 25 before we even think about sketching the box plot. And there's the correct box plot with the outlier identified. Which brings me on to my next point. If you've identified an outlier, we then need to use the smallest and largest non-outlier values for Q0 and Q1. So this even is the reason why the question told us the two lowest and the two highest. So we knew the alternative value that was going to be used for the upper boundary. So since 25 was an outlier, 20 then became the value to use for the upper boundary over here. Okay, next, when we're describing box plots, what do you need to mention? It's the median, the interquartile range, the skewness, and the outliers. Those should be things that you measure and talk about regularly. Okay, so in the example that we had here, we're going back to the example about Perth versus Beijing. The median daily temperature, straight away I spoke about the median. The interquartile range for the daily rainfall, and the amount of outliers. Not only did I mention those mathematical things, I mentioned them in context. So I was talking about a comparison between one, Beijing, and the other, Perth. You can see that here again when we're comparing school A to school B. I spoke about the median for one school, which was larger. I spoke about the interquartile range, and which was larger. I spoke about the skewness and how they compared. And then I spoke about the outliers and what that might mean for each of the individual schools. All right, so those are the 4 things to talk about whenever you're comparing box plots. Okay, so what do we want to talk about here? For histograms, don't assume that the area is always directly equal to the frequency. That's not going to be the case, especially in a question like this, where there is no frequency density to begin with. What we would have to do here is we're going to need to choose our own labeling for the left-hand side, so our own labeling for the frequency density, and go from there. So for the sake of ease, I would call this 1, 2, 3. Okay, and I'm going to use this to find areas. Right, so from here I can see that the area, the total area is going to be 112.5. So adding all of those values together, the area is 112.5. But I knew from the question that this is meant to represent 450 cars. The area is not the frequency for this particular question, but the frequency is going to be proportional to the area. How do I get from 112 to 450? So quick division, I know there's a scale factor of 4. So the frequency is actually going to equal the area times 4. So going back to any of these bars, I can find out the amount of cars that it actually represents by scaling it with 4. So 7.5, that actually is going to represent 30 cars. 60 is actually going to represent 240 cars, etc. Okay, so just be extremely careful with the histograms. Area is not always going to be the frequency, but you can use it to find the frequency, especially when it's being given to you in the question, and that should set you up for everything that you need to do afterwards. Okay, another point to make here, sometimes we're asked follow-on questions and we're asked to show or to calculate the mean. We could easily be asked for the median, the standard deviation. This histogram does need to turn into a frequency table. So converting histograms into grouped frequency table to find any of these values. The intervals for the group frequency table are going to come from the boundaries of the bars, and the frequencies, we've just looked at how we're going to find them. Okay, so without too much trouble, we should be able to convert that histogram into a grouped frequency table, and we're on familiar territory from there, and we should be able to just go ahead and find those values, either the mean or the median or the standard deviation. Okay, produce the table and take it from there.